Okay, so we're going to take a look at our video of how to read SPSS output. You know, if we were meeting in class, you would have selected your own dependent and independent variables, you would have done your own analyses, and you would be looking to see if your own hypotheses had actually worked out. We can't do that, so I got to select the variables from our undergraduate data set. And even though we don't have access to the software, I can actually show you, if you ask the software to do the analysis, what the results would look like. We don't do hand calculations in stats. They're good for when you're first learning, but when you start doing things at the bivariate level and beyond, they get a little cumbersome. First thing we want to do is make sure that we have set up our crosstab correctly. Always keep in mind, computers are dumb. They cannot think for themselves. So you have to make sure that you've specified the independent and dependent variable and what causes what. Computers don't know that stuff. So our dependent variable is along the side, and the independent variable is supposed to be along the top. It's x and y. And if you set up your crosstab correctly, that's what you should have. So how often we go to church is the independent variable, and alcohol consumption is the dependent. You can just ignore that recoded part. That's me manipulating the variable. And as long as x is across the top in columns and the dependent is along the side, red in rows, we are good to go. Now, how do we actually read a basic crosstab? Well, there's two parts to it. First, actually, let me say that there's three parts to it. First, we can tell what the variables are. I don't want to skip over that part. And their level of measurement. If we look at the independent variable, it says, how often do you attend religious services? And the attributes are never, once per year, once a month, a few times per month, and weekly or more. Now we know that's categorical. The question is it nominal or ordinal? Well, if those attributes go in order from low to high, we have an ordinal variable. And it definitely does go from low to high. So our independent variable is ordinal, but what about our dependent variable? This is alcohol consumed, and I've recoded it. We asked students exactly how many drinks they had, and then I just regrouped the data into none, a little, and a lot. So again, does that go in order? Yes, it goes in order, so it also is an ordinal variable. So both our independent and dependent variables are ordinal, and that's going to matter down the line when we look at strength of association. Now the next thing that we want to look at are actually these totals along the sides. So let me just draw a line here. And these are also called marginals. Marginals are totals. I've always preferred the term marginals. And first, for our dependent variable, alcohol consumed, the marginals are basically your univariate frequencies. So if we look at this top number right here, 207, it's telling us that 207 students said that they did not drink alcohol at all over the past 7 days. 154 said that they drank a little, and 33 said that they drank a lot. These percentages you can also look at only for the dependent variable. It doesn't work for the independent. It's basically saying that half of our students did not drink. And yes, I say basically a lot. Sorry about that. Bad habit. The other marginals for our independent variable are the column marginals, and they're down here. And here you can only interpret the top number because of the way that we asked for information. Or I should say I asked for it. You didn't do the analysis. It gives us the count for each one. It says 66 students said that they go to church never. 79 said they go once per month. 89 said that they go a few times per month, and 86 said that they go weekly. And that is really evenly spread out across all of those categories. Nice even dispersion there. And the last marginal that we want to take a look at is the one right down here in the bottom right. This is your sample size. So in all, we surveyed 394 USI students. Oops, erase. Come on. All right. Now we can take a look inside the table, and these are the cells. This is the actual table size right here. Remember, we have 5 categories of our independent variable, so there's going to be 5 columns. And we have 3 categories of our dependent variable, so 3 rows. So we have a 5 by 3 table, or 15 cells. And table size is actually important when we're going to be interpreting chi-square. But for now, let's just look inside each cell. And you'll see that there's 3 numbers. The top number is the count. The middle number is the expected count. And the last number is percentage. And if you ever forget that, it says it right here. There you go. Count, expected count, and percent. So count is your observed frequency. This is the actual number of students that we measured that ended up in that cell. So for example, let's look at this first cell here, 27. 27 students said that they never go to church and did not drink any alcohol. So the observed frequency is a cross-classification across both of those variables. 27 students never went to church, didn't drink any alcohol. And we can do that for any cell. Go down here. 4 students said that they go to church a few times per month and drink a lot of alcohol. And basically we have 15 observed frequencies, so we can go cell by cell by cell if we want. The second number is the expected frequency, F sub E. Oops, that was a really bad F. Sorry about that. Expected frequency is based on the null hypothesis. And remember, the null says there is no association. So expected frequencies are saying this is what the table would look like if there was no association. So in other words, if there was no association, only 34.7 students would be in this cell. If there was no association, 7.5 students would be in this cell. Then what we do, or what chi-square is doing, it's comparing what we observed to what we would expect if there was no association. I really don't want you to concentrate on the formula of chi-square too much, because this is the heart of it right here, the difference between observed and expected. So if we look at those top 2 numbers, the top one is observed, the second one is expected, and their difference contributes to chi-square. If there's a big difference between those 2 numbers, we're observing something that is way far off from what there would be if there was no association, then when we subtract them, we're going to get a large number. And we go cell by cell and we compare observed to expected. And the more the observed frequencies are different from the expected ones, the larger chi-square is going to be. The more they look alike, very similar in value, the less chi-square is going to be. So again, expected frequency, if there was no association, that's how many should be in that cell. Observed frequency is what we actually found in our data. And the difference between those two is how we get chi-square. And big differences give us big chi-square, which is actually going to allow us to reject the null and conclude there is an association. Now we don't have to calculate chi-square because it's given to us right down here in the little table right below our crosstab. One thing about computer output, the trick is learning what to ignore. So I'm just going to block all of this out. There's a lot of different kinds of chi-square, and we've only learned one of them. and we learned the Pearson chi-square, which you may have seen that in your text. And it gives us 3 values, and we have to report all 3 of them. The first one is the actual value of chi-square. So chi-square equals 26. I'm rounding, and that's right there. The second one is the degrees of freedom. That's right there. And you always have to report that. Chi-square is in part determined by how large the table is, and so we have to control for table size. Never, ever report chi-square without it. This third one, which has asymp, sig, two-sided, whatever, anyway, in short, that's the p-value, and that is what is going to tell you whether or not you can reject or not reject the null. Now, sometimes when you get output, it'll say 0.0000. It's not a 0 probability. The computer only goes to 3 digits, so it's 0.000 something. You just don't know what it is. And you know what? It's not important. In fact, I don't even like it when people report the exact p-value, because all we really need to know is p less than alpha. Is p less than 0.05? And 0.001 definitely is. And so this is all we need to report. You don't have to report the exact p-value. It doesn't give us any information. So again, you report all 3 of these. All right, so we've actually answered our very first analysis question. Is there an association between how often a student goes to church and how much alcohol they drink during the week? And the answer is yes, there is. I tried to make that sound exciting. Anyway, yeah, there is, definitely. And our evidence is right here. Oops, I erased. I'm erasing the evidence. All right, it's late. And we report our evidence. All right, we say chi-square equals 26, degrees of freedom equals 8, and the p-value is below 0.05. When the p-value is below that, we reject the null, and we conclude there is an association. When we say yes, there's an association, it means that we can move on and we can ask the second and third question about strength and about form. If our answer had been no, we would not move on. And I'm going to give you a really kind of a stupid analogy. All right. Let's say you ask somebody, hey, did that person punch you? And you said, yes, they punched me. Then you might ask some follow-up questions, such as, well, how hard did they hit you? And where did they hit you? Right? Okay. I told you, I'm feeling violent. Now, let's take it the opposite way. You said, hey, did that person hit you? And you said, no. And they say, well, how hard did they hit you? And you would say, are you crazy? I just told you that they didn't hit me. And then you would say, well, where did they hit you? And you're like, I just told you they didn't hit me. And you would think that you're nuts. That's what it's like if you try to move on when you say there is no association. If there's no association, how can you talk about strength or form of something that you just said doesn't exist? All right? It doesn't exist. Nothing else to talk about. Analysis stops. Move on. All right? But when there is an association, yes, you move on, and we're going to talk about strength and we're going to talk about form. So let's take a look at how we assess strength. We use these things called PRE measures. And I'm going to give you kind of a quick rundown. You have a mini lesson on PRE, which you should have read by now, hopefully. If not, I encourage you to pause and go take a look at that and then come back. So assessing strength, we're basically saying, all right, this causes that. It's influencing it. They co-vary. How often somebody goes to church moves at the same time and with how much somebody drinks. Covariation, that criterion causality. But now we want to say by how much. Is it a big influencer or is it just a little bit of an influencer? And that's what we mean when we talk about strength. Yeah, it exists, but how strong is it? For nearly every procedure in stats, we use this whole host of measurements called PRE, proportion, reduction, and error. Each one has a kind of an individual formula, but they all do the same thing. They're telling us how better we are at predicting the dependent variable when we use the independent variables as predictors. I always just think of it as we are playing a guessing game. We are trying to figure out why some students drink more than others. All right? Why? Okay. Well, we've determined that how often they go to church is part of that reason, but how much? How much of a reason is it? You know, is it a big influencer or kind of a weak one? PRE measures, all of them vary between 0 to 1.0, or if you prefer percentages, 0% to 100%. Now, those are the extremes. You can never have a negative PRE measure, and you can never have one that goes over 100%. 0 means the independent variable does nothing, all right? It has a strength of 0. You're only going to get a 0 if there's no association. 1.0 or 100% is perfect prediction. What that means, if I got a PRE of 100%, it means I make absolutely no mistakes. I can perfectly predict how much a student's going to drink if I only knew how much how often they went to church. In other words, I could go through every student at USI and ask them a single question. How often you go to church? They'd tell me, and I'd say, this is how much you drank. And they would say, yes, you are right. You are 100% right. And I would never, ever, ever make a mistake. That never happens, by the way. Obviously, why people drink alcohol, there's a gazillion reasons why people drink alcohol. We're just trying to figure out how much of a reason going to church is. As a side note, this is why natural scientists often make fun of social scientists because we have such low thresholds for our PRE measures. We basically say anything from 10% or 0 to 10% is considered a weak association. 10 to 20%, we think about that as moderately strong. And 20% or above, we say is strong. Now, just for comparison, in the natural sciences, in order to say, conclude a strong relationship, you need a PRE measure that's probably in the 60s or 70s. Now, honestly, that is because natural phenomena is easier to predict than humans. Humans are extremely complex. Again, why do some people drink alcohol? There's a whole host of reasons, and we're trying to model that behavior. We're only modeling it with one variable. We're not going to explain a lot of the reason why some people drink alcohol, but we can assess how much, we explained. Now, these are just guidelines. They're not super strict. They're just for you to kind of report what is called the relative strength. And it just gives you a guide for saying something is weak, moderate, or strong. And again, if you get a PRE that's like 9 or 11%, you can call that weak, or you could call it moderate. It's up to you. There's not specific cutoffs here. But if you got a PRE measure, for example, of 5%, you would say the relationship exists, but it's weak. When you got a PRE of 25%, you'd say the relationship exists, and it is strong. The higher the value of that PRE, the stronger it is in predicting the dependent variable. In other words, the bigger influence it has. Now, the second thing that we can say about PRE measures is one that is actually more interesting, but it tends to confuse students a little bit more. But what we say is percent of variance explained. Now all PRE measures are reported in decimal form, so let's just take lambda. If it's 0.05, then that's also 5%. Again, if total explanation is 100%, it's saying that we got 5% of it. We got a little piece of it. There's 95% out there that we are just kind of floating in the wind. We have no idea, what these other things are, but we got 5%. If our PRE is 20%, it means we've explained about 1/5 of the total variance. If it's 10%, 1/10, and so far. It's telling us how much of the pie we were able to get. Sometimes it helps to think about predicting. The real technical explanation for the PRE value, it says that it's the percent better we are doing in predicting the dependent variable. So if I know how often a student goes to church, then the PRE is going to tell me how better I am at guessing how much alcohol they drink. Now I'm going to simplify this. You take the PRE measure, and here's the generic interpretation. You say X, and then insert the word explains, and then it's going to be whatever the PRE value is, and say of the variance in the dependent variable. And so then all you have to do is find the number and fill that in, and then replace these with the actual name of your variable. So I would replace X and say how often a student goes to church explains blank percent of the variance in how much they drink. And you can do that with any of them. So that's the second kind of interpretation that you can make with a PRE measure. Now I'm going to quickly review that because when I ask you on the quiz, you're going to get confused. So if you are given a PRE measure, and it doesn't matter which one it is, don't get caught up in that. All PREs are the same. I'm going to ask you about relative strength. And you're going to look at the value, and you're going to tell me if it's weak, moderate, or strong. Sorry, I'm not going to spell those out. And then I'm going to ask you for what I usually call the PRE interpretation. Sorry, my voice is cracking. Yes, my throat is still messed up from the COVID virus. Okay, the PRE interpretation, this is the percent of variance explained. So this is when you say X explains, blank percent of the variance in Y. And you're going to insert the variable names. It's telling you the percent that we got. Right? Now, let's take a look at where we get the PRE information from an output. If we look at the output for our analysis, there's more than just the crosstab, which we already looked at, and the chi-square. Right up below that is going to be where your PRE measures are. Now, in order to fit these all on the page, I had to shrink them really low, so I'm going to pause and get them blown up for us. Okay, so this is a little bit larger for us to deal with. Now, one thing that's really unique when working with categorical variables is there's just not one perfect PRE measure. Almost every other procedure we do, we've got, we just use one PRE, but with categorical variables, not so lucky. So we report our PREs in pairs. So there's always two of them. And that's because one of them tends to usually underreport and the other one tends to overreport. So if we report both of them, then we kind of know that, the truth is somewhere in the middle. Another thing we have to pay attention to is what the level of measurements of our variables are. If one or both of your variables are nominal, then you need to use lambda and tau, technically Goodman and Kruskal's tau. And if you forget that, look at how nice the little output is. It's saying those are the nominal measurements. And again, even if one of your variable is nominal, you have to use lambda and tau. If both, and only if both of your variables are ordinal, you would use Somers D and gamma. And then you ask, well, okay, so why is gamma in its own little box? Well, it's... Okay, I have to pause my cats. My cat is meowing. Yay. Oh, the joys of working from home. All right, the cat's taken care of. And just for the record, I have one cat. I'm not the cat lady, just so you know. I just have one very loud cat. All right. Where was I? I was talking about the PRE measures. You're going to get 4 of them, and you have to decide which 2 are appropriate for the variables that you have. Both my variables, church attendance and how much somebody drinks, are ordinal, so I am going to use the ordinal by ordinal measures. So what I like to do is I just don't even look at this. We don't need it. Just cross it out. It's irrelevant. And then why is why is gamma down here in a box all by itself and the other 3 are up here? If you notice, one says symmetrical and one says directional. All that means is that for the 3 that are up there, lambda, tau, and Somers D, it matters. The value is going to change depending on which is the independent and the dependent variable. And it's going to give you all 3 of them, and you have to select the appropriate one. For gamma, it doesn't matter. It's symmetrical. It goes both ways. It doesn't matter if you switch x and y around, you're going to get the same amount. So for our strength measures, we need D and we need gamma. And if I look at Somers D, so I'm right here, there's 3 values. And the top one says symmetric. Second says recorded alcohol beverages consumed past 7 days, dependent. And the bottom one says how often do you attend religious services, dependent. So which is our dependent variable? We never ever want the symmetric one, period. So we just have to pick the number that goes with our dependent variable, and ours is alcohol. So it's this one right here. So it's negative 0.118. Gamma, there's just one that we have to look at, and it's right here. It's negative 0.207. And then again, we don't need anything else. All of this stuff, and we only needed 2 little numbers from it. But welcome to the age of computers. So I have 2 PRE measures. Oops, forgot the negative sign. Now, the first thing is you can ignore the negative sign. Technically, it gives us form of the association if we have ordinal variables, but, that always tends to really confuse students, and if I'm not there in person to correct it, then it gets even more frustrating. So we just look at the absolute value when we are assessing strength. So don't tell anyone, but I'm just going to erase these negative signs and just kind of tell you to ignore them as well. And just look at the value. So we have 11.8% and 20.7% if we converted them to a percentage. So is that weak? Is that moderate? Or is that strong? Well, Somers D is saying it's moderate, Gamma is saying it's strong, so I would probably say it's moderately strong. Again, this is not rocket science here, so it just has to be a reasonable interpretation based on the numbers. And remember, one always over-reports and one always under-reports. In this case, Gamma always over-reports and Somers D under-reports. So we report both. So I have a moderately strong, predictor. In other words, how often somebody goes to church is moderately to strongly related with how much alcohol a student consumes. Now, the second thing that I want to do with these numbers is I want to convert them to a percent, and it's percent of variance explained. So, again, just insert your independent variable. So, how much a student attends church explains 11.8 to 20.7% of the variance. And just for convenience in, drinking. Actually, it's drinking alcohol, but whatever, okay? And that's the PRE interpretation. And I want to report both of these. So I'm going to say how strong it is, and then I'm going to give the percent of variance explained interpretation. So make sure you do both of those. Okay, so moving along, we've now answered 2 questions. It's like 31 minutes in, and we've answered 2 questions. But there's an association. Again, there's the statistics up there. That's our evidence. And then we assessed how strong it is. And again, the statistics, you have to report what they are as your evidence. So we'd report both D and gamma. And then we would say 2 things about it. The relative strength. In our case, it was moderate to strong, and the percent of variance explained. Now, the last thing that we want to look at is form of the association. Now, to keep things simple here, we're going to be taking a look at column percents and odds. More technically, odd ratios. So we need to go back and take a look at that crosstab. So now, taking a look at our original crosstab, if you remember, there's 3 numbers in each cell. The top one is the observed frequency, the middle one is the expected, and then the last one here is the one that we are going to use for form. It's the one with the percentage, and it's the column percents. And again, if you set up your crosstab correctly, then you can use them. If you did not, if you've got your independent and dependent variable turned around, these are useless. So remember I said computers are kind of stupid. Basically, they can't assess form for you. It takes somebody looking at it and with knowledge of the variables and trying to, actually assess it. At least when it comes to categorical variables, it does. So one thing that we can do is simply compare the percentages going across. Again, it's not rocket science, and the easiest way to work with column percentages is to simply pick one row. Oops. And then we compare. Man, it's too late for me. All right. And then we compare these percentages to one another, all within the same row. And it doesn't matter which row you pick, the column percentages are compared across the row. And you don't even have to choose all of them. In fact, for convenience sake, usually you only pick the ones that are at the extreme. So let's say that I want to work within the none category, those people who didn't drink, and I would compare those who say that they never go to church to those who said that they go to church weekly or more. And I write a sentence about it. For example, among our students who say that they never go to church, 41% had not drank alcohol. However, for those who went to church more weekly or more, sorry, I'm a little awkward, weekly or more, over 67% said that they did not drink alcohol. In other words, I just make a simple comparison. And there's no rules here. I mean, I didn't have to use that column. I could have used a lot and compared these. These are actually really small percentages because there weren't that many people that drank. But the simple rule is is you pick one row, don't cross over rows, like don't compare this to this. It doesn't work that way. You have to compare the column percentages within a single row. And then you just create a sentence about it. Now the other thing that we can do, and one that I think is a little bit easier, is what I call odds ratios. Actually, I don't call them that. Everybody calls them that. And we're just going to do a simple odds here. And just a little bit of trivia. For those of you working with a textbook that's later than 1994, the part about odds ratios in your text was written by me, just so you know. Yay. For the odds ratios, you're going to compare the odds of being in one category versus another. And you can do relative odds, which are a little bit more complex, but we're just going to work on simple odds, and that's all I'm going to require of you. Now, to calculate a simple odds, you're going to have to select one category in your independent variable, and it's completely up to you which category you want to pick. You know, there's no steadfast rule. You could select those who never go to church. You could select those that go to church, weekly or more. It doesn't matter. It is researchers' preference. The only thing when you're calculating odds is you really need to keep track of what you've chosen to do. So let's say that I'm interested in these people who go to church a lot. I'm going to write that down. So those who go to church weekly, technically weekly or more. Once I've selected the category of people in the independent variable I want to analyze, then I go to my dependent variable, and I'm going to need to pick an over and under to create the odds. If you have a 2x2 table, there's only 2 you can select, so it's pretty obvious, but in this case I have 3. There might be 4 or 5 categories. And again, usually the extremes work better, but let's just use these 2 here. So I want to create the odds of drinking no alcohol versus a little alcohol. Again, over, under. If you ever done any betting, then you probably have calculated odds before. So again, you just want to keep track of what it is that you're doing. So we're going to calculate the odds of drinking no alcohol versus a little alcohol. And I could reverse these. It could be a little alcohol over a non-alcohol. It's up to you. There's no right or wrong way other than just keep track of what it is that you are doing. Because whatever you want, whatever you put at top is the odds of being there versus the bottom. The odds of being in the top category versus the bottom. So if I switch them, obviously my interpretation is going to be different. Then all I need are the frequencies for those who attend church weekly or more, and for the none and a little category. And so for none, it's 55. And for a little, it's, 26? And I'm going to fudge it here. That's roughly, 3? 2? 2, sorry. I don't know where I got 3 from. Anyway, 2. It's a little bit more than that, but whatever. This is our actual odds ratio. And how you interpret it is you are 2 times more likely to drink no alcohol versus a little alcohol if you attend church weekly. You are, insert odds, twice as likely to be here versus here if you are this. So let me interpret it again. Take your odds. You are twice as likely to be in the top category versus the bottom category for the attribute you selected of the independent variable. Now I'm going to do another one, because you get the hang of it pretty quickly. And what happens if you calculate an odds ratio by the way that you set it up? It's a decimal. It's not that difficult. I'll just give you a quick demonstration of it, and we'll just do another one here. This time I will pick the once a month category. Again, you just want to write it down. Makes interpretation easier. And instead of doing none on top, let's put a little over none. So now, whatever we calculate, it'll be the odds of drinking a little alcohol versus no alcohol if you go to church once a month. And then we just need these frequencies. So it's 26 over 51. And that's going to be almost exactly half. So it's a decimal. When it's a decimal, if it's anything less than 1, it means you're less likely to be in the top category versus the bottom category. Anything over 1 means you're more likely to be in the top category. When it's a decimal, instead of saying more likely, we use the word as. Otherwise, it doesn't make grammatical sense. So, but other than that, the interpretation's the same. You are 0.5, or more simply, half as likely to have drinking a little alcohol versus no alcohol if you went to church once per month.